The goal of this presentation is to underline the benefits of FLAIR fusion analysis in private practice when following MS patient. None of the author has any conflict of interest, and this study has been conducted in a private practice center. Multiple sclerosis leads to millions of MRI scans around the world. Clinical modifications, treatment evaluation are the main triggering factor to control MRI of this patient, looking for time dissemination. We use Magnim's criteria to assess time dissemination and especially the apparition of new FLAIR hypersignal. The first technique is the frame-by-frame comparison of successive three-dimensional FLAIR sequences, which can be time-consuming, especially for patients with high lesion load. The best technique seems to be the subtraction between successive FLAIR sequences, according to the literature, but subtraction tools are not always available on the post-treatment packages supplied by the main MRI providers. For example, our solution is limited to subtraction of sequences acquired during the same exam, intra-exam, and subtracting sequences of different exam needs for us an investment in another advanced post-treatment. Perhaps you could find free software to do the job, but it's at the problem of the loss of time to export the images. The third technique is the FLAIR fusion, widely available. How does it work? In our case, the post-treatment is realized on Siemens Singovia software. The FLAIR sequences of 2 successive exams are loaded, co-registered and fused, and a blue clot is applied on the oldest FLAIR sequences. On the fused sequence, new lesions remain in white, whereas old lesions are in deep blue. It doesn't work if you apply the clot on the new exam. It works for periventricular lesion, it works for deep white matter lesion, also for increasing lesion like in the middle. It works for cortical and subcortical lesion. It's more difficult to see, but it works. It works in the posterior fossa, on the trunk, and the cerebellum, whereas lesions are peripheral or central. And it works for patients with high lesion load, for tiny lesions, high lesions. We then conducted a retrospective blinded study to evaluate this technique on 21 patients who had successive MRI in our imaging center. For each anonymized patient, we assessed dissemination in time using frame-by-frame comparison and FLAIR fusion at different time to avoid the results of the first technique influencing the result of the second. A neuroradiologist and an MRI technician who accept the role of the new resident, because we don't have residents in private practice center, participated to the study. We assessed the number of new MS lesions detected, the time needed for interpretation, and the agreement between readers with both techniques. The time for interpretation is significantly reduced for the neuroradiologist, about 60%, not for the technician. The number of new lesions detected, whereas not significant, probably because frequently similar for both techniques, is sometimes higher with FLAIR fusion, but never lower than with frame-by-frame comparison. So the gain of time is not associated with a decrease of the number of new lesions detected. In terms of agreement between readers, the agreement for FLAIR fusion is higher than the agreement between readers for frame-by-frame comparison. The study has some limits. The number of patients, with a higher number, the difference of number of new lesions detected could be significant. The technique has some limits. Some technical issue like imperfect co-registration, easily recognizable with the double control appearance of the image. The learning curve for your technician to generate the fusion sequence with the good contrast and to make also your eyes sensitive to the difference of colored contrast between all the new lesions. Probably this technique is less powerful than subtraction for decreasing lesion. To conclude, FLAIR fusion is easy to implement. It's cost-effective because inter-exam fusion is included in all post-treatment package, whereas inter-exam subtraction is not. It provides nicer and easily understandable images for the clinician, and overall it permits to work faster and probably to detect a higher number of new lesions. Thank you.
Any questions from the audience? Can we quickly comment how you actually do it with a single via?
Can you repeat? Oh, I.
Can we quickly tell me how to do it? With a single via, I mean, so you go to the single via.
You go to single via, you load the two sequences, and you've got a function to fuse the two sequences. You've got an option to make the co-registration, and after you apply the clot, you choose to apply the clot to the old sequence, and it generates automatically the new sequence with the clone, like it's like the first level. You load the two sequences, and you apply the clot on the old, and you've got the results.
Thank you.
Maybe you pointed it out and I missed it. Was there any reference standard, like who determined the validity of whatever we were calling new or stable, or were we simply comparing it to?
No, simply comparing it
to individual reads?
Does this have volumetrics capability as well, or is that would be like a separate thing?
It's a separate thing.
But within the same, also within the single via, or is this have nothing to do with? This does not do volumetrics at all.
There's nothing for us on single via to make volumetric assessments. It's another software, and it's a post-treatment, another post-treatment.
Gotcha.
These are two-dimensional 5mm slices. What
No,
is this?
only three-dimensional FLAIR sequences. I think
I mean, the two sequences. I mean, the thing is, are these two sequences identical in acquisition?
Yes.
Or so how do you ensure that part?
both are 3D FLAIR sequences.
Also, they're 3D FLAIR sequences.
Yes.
Okay, so.
Okay.
Great, thank you.